So welcome everyone. We're going to wait a few more minutes for folks to trickle in, but thanks for joining us today. All right, thanks to all of you for joining. We're going to wait just a few more minutes as I see more people are still entering the webinar, but we'll get started in just 1 or 2 minutes. Thank you. All right, everyone, it's about 2 minutes after 2, and I figure we'll just go ahead and get started. Welcome to the webinar on Advanced Grid Solutions, which is hosted by the NASEO Electricity Committee. My name is Catherine Reed, and I'm a Senior Program Director with the National Association of State Energy Officials, also known as NASEO. For those who aren't familiar with NASEO, we're a national nonprofit that supports all 56 state and territory energy offices throughout the United States. Next slide, please. We serve as a resource for and about energy offices on a wide spectrum of energy topics through a variety of means. One of the ways we do this is through events such as this. We host regional and national dialogues on emerging energy issues like this event today. NASEO has established standing committees, task forces, and working groups on the broad spectrum of energy topics of interest to state energy offices. Next slide, please. So, though the topic of today's webinar is likely of broad interest, today's webinar is intended to support the NASEO Electricity Committee. And you can see here, the Electricity Committee convenes state and territory energy offices on the broad spectrum of electricity-related matters. And we're also guided by a leadership team, and we're thrilled to have one of our leadership team members join us today for the roundtable discussion. Next slide, please. So it goes without saying that the topic of transmission is dominating the energy news world. It's certainly having its moment. So a big focus is on our aging grid and the need for more transmission to meet the multitude of goals: increased demand growth, resilience, reliability, affordability. By some accounts, the US grid must more than double its current electricity capacity. So we're especially excited today to explore advanced grid solutions, and we're using that term as an umbrella term of the technologies that focus on increasing the efficiency and the performance of existing transmission infrastructure. So this includes grid enhancing technologies as well as advanced or high performance conductors. Many states are exploring the potential use of these technologies. So perhaps in concert with undertaking the expansion and build out of new infrastructure, they're looking at ways to improve the infrastructure they already have. Before we go over our agenda, I just want to send out a special thanks to the Watt Coalition, as well as ACOR, for helping us set this up and put us in touch with these great speakers today. And thanks to all of you participating in today's webinar, taking time out of your, I'm sure, busy schedules. Very briefly, we're going to have 2 presentations. We have 2 speakers today who will share their respective research and findings on the topic of grid enhancing technologies and high performance conductors. We have Pablo Ruiz, who is CEO and CTO of New Grid, to talk about grid enhancing technologies. He'll be followed by Casey Baker, who serves as Senior Program Manager with Grid Lab. And then following those presentations, we'll have a brief time for Q&A, and then we will turn to the states. We're really pleased that 2 representatives representatives from 2 state energy offices in states where work is being done on this front are joining us today. So James Lester, who's a senior advisor with the Colorado Energy Office, and Jeff Blend, who's an energy resource professional with the Montana Energy Office. And I'll just make a very brief note. This is a webinar format, but we do want to hear from you. The 2 presentations will be recorded, and then following that, as soon as the Q&A begins, we will no longer record. And we'd love to have you pose questions in the chat or the Q&A function at the bottom of the screen. So please know that we really do want this to be as interactive as possible despite the format of a webinar. So without further ado, I'd like to introduce then our first speaker, Pablo Ruiz. So Pablo, if you'll take it away, please.
Thank you, Catherine. And good afternoon and good morning, everyone. Nice to speak with you about grid enhancing technologies. As Catherine was saying, my role is with NewGrid. NewGrid is a topology optimization technology company. It's one of the grid enhancing technologies. Today at the webinar, I will be representing the WATT Coalition. WATT is a coalition of looking to promote grid enhancing technologies. Members include technology companies, but also utilities, and advocates and users. So going to the next slide. I think we'll be preaching to the choir, indicating that we need to significantly increase transmission capacity, grid capacity, for a number of reasons, and very quickly. Including increasing demand from new industry, data centers, also to improve and deal with resilience events. One of the studies indicates 57% increase in capacity over the next 10 years or so. That is clearly a daunting task, and we need every tool in the toolbox to be able to reach that increase. Let's go into the next slide. So I will be covering grid enhancing technologies, and Casey will cover advanced conductors. Grid enhancing technologies are effectively technologies that consist of hardware, software, or a combination that provide increased visibility and control, or control means, related to congestion management. So this is, again, increased visibility or control. That increased visibility and control effectively will result in increasing capacity, efficiency, reliability, and safety. So a number of different attributes in a dynamic fashion. So being more specific about what these technologies are, they include dynamic land ratings, which provide measurement and calculations of the actual capacity, so that operators and planners can rely on information from the field, as opposed to, or maybe in addition to, just calculated values based on standard assumptions. So that's dynamic land ratings. Again, increased visibility on the rating side. Advanced power flow control. These are devices that redirect flow to lines with additional capacity or not fully utilized capacity, and away from bottlenecks, looking to increase the transfer capability of the network in locations where those devices are installed. And topology optimization technology, that's the NewGrid technology, is software that finds how to better utilize the existing equipment, mostly looking to reconfigure the grid to, again, better redistribute flow around and reroute flow around bottlenecks. So if we go to the next slide, in terms of the benefits, what gets due is to improve the management of congestion, and the implication, if we go to individual benefits of that improved management, is that the cost of managing congestion go down. There's an increase in grid utilization, increase in the transmission capacity, or the effective transmission capacity of the grid, even if you have the same wires. By improving the utilization, you can move more flow. Improve resilience and reliability when you need it. The dynamic nature of the GITS are critical for that point of view. Better use of the existing infrastructure and rights of way, so that's lower. And these are relatively low capacity and fast deployment type of technology, so that they can provide immediate impact to complement all the other tools in the toolbox to increase transfer capability. So that's the high level summary of the benefits. So going to the next slide. I'll illustrate with a specific case study. NuGrid has been working with Alliant Energy for the last, I think by now, 3 years. On this slide, you can see the impacts of our working with Alliant, specifically with the IPL, the utility in Iowa, Interstate Power and Light. The role of or the approach that this scope of work has taken is mostly an advisory. So rather than incorporating the technology with, in this case, the transmission operators or the RTO, in this case, MISO, is to do the calculations outside of the transmission operations or control room and look for the low-hanging fruit type of opportunities. And even with that caveat, and I will recognize the support from ISO. Yes. All right. The impacts can be very significant. So over 50% reduction in the cost of congestion for the IPL transmission customers. Going to the next slide. So the grid enhancing technologies have been available for many years, but the wide adoption has been difficult for a number of reasons, key of which is institutional inertia. And of course, it doesn't help to have misaligned incentives. So the goal would be to have a framework that supports innovation, where utilities are encouraged to innovate for customer benefits, and prioritize the system and process changes and improve incentives. Going to the next slide. So in here we summarize how what can NASEO members could do, or some ideas to support GITS adoption. One class of suggestion is to support legislation at the state level. There have been already some successful examples of legislation passed this year in Minnesota, Maine, and California, and each one of them takes a slightly different approach, but all of them tie the grid enhancing technology requirements to state jurisdictional processes, and that's key. So these could be related to the PUC realm, including clean energy goals, resources, and also siting, and avoid transmission rates. But even with that caveat, a lot can be done at the state level. And just to provide a little bit more flavor of what these do. So in the case of Maine, the requirement is for the PUC itself to conduct a study of the opportunities and the relevance for the state. In the case of Minnesota, is for the utilities themselves to incorporate in planning, whereas in California is looking at also mandate for the utilities to study get specifically in relation to a number of different benefits. Some of those benefits we were talking about a couple of slides ago. So slightly different approaches to achieve the same goal. And I would say that these go hand in hand and complement the Order 1920 from the federal level. Now, in addition to supporting legislation, NASEO members can leverage soft power, and two specific ideas are for the governors to sign on to the White House federal and state modern grid deployment initiative. There have been 22 states already signing on to that initiative to deploy advanced transmission technologies. That's one. Another one is to lead GRIP Round 3 applications. This is from the DOE Grid Deployment Office. the third solicitation will be coming out soon. And what that provides is effectively a 50% or significant subsidy of these technologies, typically at the 50% level of magnitude. But while we are highlighting those two, there are many other opportunities to leverage the soft power, including participating in different FERC proceedings as well as regional stakeholder processes. So with that, I'll stop and looking forward for the Casey presentation and the Q&A session.
Thank you, Pablo, and thank you, Catherine, for the invitation here. Good morning, good afternoon, everyone. My name is Casey Baker. I'm with Grid Lab. We're a nonprofit technical support organization focused, and my role is focusing on transmission. This past spring, we put together this report that I've linked here in the document, identifying the opportunity for advanced conductors to rapidly increase the transmission system, the capacity of the transmission system we have today. So Pablo identified several technologies that are incredibly useful in that near term, 18-month, year to 18-month timeframe. At the same time, there's many efforts being made to increase transmission capacity in the long term, so the next 8 to 12 years, and that's long-range transmission planning efforts. Where advanced conductors fit in is kind of in the middle of those two efforts. And so I'm going to talk to you a little bit about that technology today. Go ahead to next slide, please. The main thing you all need to know about advanced conductors or just transmission rating in general is the transmission capacity of the system is limited by how much, in many cases, by how much the line sags under loading. So as you run power through a power line, it heats up and it starts to sag down. And as you can imagine, that's a bad thing. That is what triggers wildfires or triggers safety risks. And so the less you have sag, the more power you can push through the line. And there's a lot of different ways you can do that. The first and most straightforward way is just raise the towers up. If you raise the towers up, it can sag more, you can push more power through the line. And there are firms that are looking at just doing that. Or you can remove the ground below the line so that when it sags, or you can retension the line, it doesn't sag as much and it doesn't introduce those safety risks. Next slide, please. But advanced conductors approach this problem by using advances in material science. And what they've done is they've replaced the core of traditional conductors, conductors being the wire that is actually sitting on the power line. The core of that wire is the same core technology that's been used for the last 100 years, and it's just high tensile strength steel. And that's the same technology that's been used in the vast majority of cases of power lines across the US. And what we have found over the last 15, 20 years is there are advancements that are increasing the strength of that technology and reducing, or in some cases even eliminating, that sag. And when you eliminate that sag combined with adding more aluminum to the wire, you can push more power through the existing wire. And there's a couple different ways to do that. So really what we're talking about is just the wire. This is a sample of the ACCC wire, which is a composite core. And then there's also advances in just steel strength that can also increase the amount of power you can push through a wire without introducing new safety risks. This new technology is you can increase the capacity of the wire by 2 times and sometimes even 3 times. You can simultaneously reduce the energy losses, so there's an energy efficiency benefit. And you can increase resiliency because these new wires, because they sag less, are less likely to trigger outages or wildfires or anything like that, because they're less likely to swing into places where they could get interference. Next slide, please. Our study focused on this technique called advanced reconductoring. And the idea here is you have an existing power line, you remove just the wire, and when you've removed the wire, you can do a lot of good things. And in many cases, the structures that are there today don't need any rehabilitation. But in cases where the structures have been around for 60, 70, 100 years, you do need to do some rehabilitation to the towers, and there are techniques to do that. You can raise the towers, you can repair foundations, etc. And in other cases, you do have to replace the structure entirely. But the main benefit here is that you're reusing the existing rights of way. One of the biggest barriers to increasing our transmission capacity is just the right of way and siting of new transmission structures and lines. And what advanced reconductoring does is allow you to increase the capacity of the system without increasing the footprint. So once you've removed the wires, you've rehabilitated towers as needed, you then install the advanced conductor or high performance conductor in the exact same place where the old conductor was, and you've doubled, or like I said, in some cases even tripled the capacity of the line. As you can imagine, this provides a huge amount of benefit where it works without having to increase the footprint and with minimal siting or permitting requirements. Next slide, please. While you have the wire down, you can also investigate advanced tower design, which, as I pointed out, if you can improve the strength of the towers or the height of the towers, you can increase how much power goes through that footprint as well. And there's a couple different technologies that have been developed to do that. One specific technology, if you need to absolutely move a huge amount of power through a very small corridor, high voltage direct current conversion is a technique that's being used broadly in Europe to increase, and has been used in the US, to increase how much power can be put through a footprint. So this diagram here along the right is showing that one HVDC line on the bottom is moving about as the equivalent power of 2 of those lattice AC structures across the top. So the takeaway here is that there are plenty of technologies that can increase the amount of capacity going through existing rights of way. Next slide, please. Next slide. Sorry, I forgot there was transitions on this. Yeah, just go through that. These high performance conductors, while they are relatively new in terms of utility timeframes, they've been around for over 15 years, and in some cases even 20 years. And across the world, we're seeing broad deployment of the technology because there is recognition that being able to push as much power through the existing rights of way is increasingly important. And that optionality of being able to install a transmission line and have a huge amount of headroom provides economic development benefits as well as resiliency benefits. So this is a tested technology that's not just coming out today. It has been around for over a decade and has been deployed around the world and in the US. Next slide, please. So why, if it's so great, why isn't it being deployed everywhere? The first thing is high upfront costs. The conductor itself does cost more per foot than that traditional ACSR technology. One thing too, in many of your states, utilities are incentivized based on the structure of the regulatory environment to invest in major infrastructure investments as opposed to piecemeal, small marginal investments like advanced conductors or like grid enhancing technologies. Utilities are intentionally slow to adopt new technologies, and that's generally a good thing. We don't want the grid to suffer, outages by being rapidly adopting new technologies. However, like I mentioned, this is not necessarily a new technology in the grand scheme of things. It has been around for many years now. Operational engineering changes are required, and different technologies are needed for different situations. Not the advanced conductors or high performance conductors do not work everywhere, just like traditional conductors do not work everywhere. There's going to be a right tool for the job in each case. However, what we found in our study is there are many technologies that are not being used, and there's a significant opportunity if utilities move forward to start using those technologies to reutilize our existing footprint of our transmission system and increase transmission capacity. Next slide, please. So where can energy offices step in? One more slide. The barrier, I discussed a little bit about the barriers. Here are some different options that different energy offices or states are looking at. You can think about it as 3 different categories of options. You can study it, you can use a carrot, or you can use a stick. And we're seeing a lot of states embarking on the study option, which is require the utilities to study the use of GETs or advanced conductors, or study areas where they might make the most sense. You can, the carrot option is things like a shared savings mechanism, incentives mechanism, and then the stick would be more things like an energy efficiency standard that says you shall use these technologies to address congestion or anything like that. So a couple different options and a couple different categories. What works for your state is going to be different from what works in other states. Next slide, please. Yep, and that's it for me. Thank you.
Well, thank you all so very much.